Great. Great. Okay, so all classes will be recorded, but I only can keep them for 1 week. Okay, so if something happened and you could not attend that specific class, you have 1 week, 7 days to watch and take your notes before I delete. And I need to delete the files because they are huge, like 3 hours of a class. It spends a lot of space in my cloud in the Google Drive. So you can just achieve the Google Calendar, and there you can find the record. I can do this in the next class. In the second one, I can show you how you can do that. Unhappily, I cannot do this right now because we are recording right now, only after some hours, like 2 or 3 hours in the end of the class, the link with the file will be shown in the Google Calendar. So you can see there, okay? And guys, my English, it's not perfect, okay? I can talk, I can easily understand everyone, but if something happened and you could not understand me, just raise your hand and you can ask, and I can try to describe in another word or try to find a best way to explain an idea, okay? Please don't keep your doubts with yourself. Express yourself because I can understand that you can easily understand me, and it's what I really want. I really want that in the end of this specific course, everyone here has a deep experience and a deep understanding about soil classification. Unhappily, the students that are not attending this course in person, they are not in Brazil. They cannot attend a field trip. We will plan a field trip during the semester. So a field trip of 2 or 3 days. I'm not sure yet. We will classify soils in the field. So it's great. I tried to record these field trips in the past and I had a very bad experience. So sorry, people that are not attending the course in person, unhappily, or at least in Brazil, unhappily, we cannot do that. Okay, but at least I will try to share the photos and some description that we did in the field, and you can have some information, okay? And just before we start, I would like to share another information. It's that Brazil opened a call for masters and PhD students. If you plan to do your PhD or your master here in Brazil, we have scholarships for this. Okay, I will share more details about this information by mail in the next few hours. Okay, in the end of this day, I will share this, but it's interesting. It's quite interesting for you all. We have scholarships in my postgraduate program in soil science and plant nutrition. We have 6 positions for PhD candidates and 6 positions for masters. So yes, you can apply for them if you want to do that. Okay, but I will provide more details, and if you have any doubt or if you are interested on that, just reply me and I can provide more information. Okay, so let's start our class. I will share my screen, just a second. Okay, share my screen, share my entire screen. Great. I hope you can see my screen now and this first class. Okay, great. So let's start. Okay, guys, I cannot see you all. So if you have a doubt, please raise your hand or open your microphone, okay? And I can hear you, no problem. So here it's my email address. You already receive some correspondence from me. You can use this email as any kind of when you decide, okay, when you want, if you have any doubt, if you have any question, you can email me. You can just type, or we can schedule a specific meeting and we can talk briefly, like, okay, JJ, I have some doubts about this specific topic, and I really need to understand better. Or, oh, I found the soil in my country, in my city, and I would like to understand better how the soil was formed, or how can I classify this specific soil. I can help you with that. Okay, just email me. I'm a very, very easy person, okay, and an accessible one. So please, don't be shy. You can email me and we can talk very easily. Okay. As I said, the course is called International Systems of Soil Classification. The code is SOL627. So any other information that you need, if you want to talk with me, just mention this specific code so I can remind, oh, okay, it's one of my students. Okay. It's just because I also teach other courses, and sometimes it's quite hard to understand which course are you talking about. Okay. So as I said, we will use this two systems in our course, and I decide to start with soil taxonomy. So this is the document that you all need to read. I will share the PDF file of this document, and it's quite easy to read and access it. And we also will use the field book for describing and sampling soils. This field book, it's huge, but it's quite good and important, okay? JJ, why you start with soil taxonomy? Because it's much easier. Yes, believe me, it's much more easier than WRB. WRB, it's more complex. We have a lot, like a lot of details. So it's much more difficult and harder to describe and classify soils, especially classify soils using WRB. But if you ask me which I prefer much more WRB. The WRB, the World Reference Base for Soil Resources, it's a quite perfect, quite perfect system. And why it's so perfect? Why it's so good? Because it's a system produced by everyone. Like, we have people from the majority of countries, from all countries, no, but from all continents, contributing, improving the system. So we have people from different backgrounds, people that knows soils in different regions, like people from Japan, from Korea, from Nigeria, from Brazil, from the US, from Italy, and from different countries. And everyone is improving the system. Because of this, WRB, it's a very good system. It's a very consistent system. And soil taxonomy, they have some contributions from other countries, but basically from Americans, from people from the US. So of course, a system that has more contributions and from people from different backgrounds, they improve faster and they are much better. But let's start with this one, because soil taxonomy, it's also quite good. In some countries, you only can find the soil description and classification according to soil taxonomy, especially in South America, in Latin America. A lot of countries, they use only soil taxonomy. So let's plan to visit Peru. You only can find information by soil taxonomy. So it's quite important to know that. Even some countries in Europe, they also only use soil taxonomy. I don't know why, but they use. So we need to understand the soils, and because of this, we need to understand soil taxonomy, okay? So this is my first question for you all, okay? What is soil? How can you define soil using your words, using common words. Okay, you don't need to consult a book or an article, just your mind. What pops up in your mind when I ask you, what is soil? Please open your microphone, raise your hand, and answer me. Yes, please go ahead. Okay, let me just.
Hello, good afternoon, everyone. Am I audible? Hello, can you hear me?
Yes, perfectly, perfectly.
All right, thank you so much. My name is Marvelous, and if I should define it, I would say that soil can be defined as a basis of the earth surface whereby agricultural activities are carried out, and then
Oh,
it can be in layers, it can be in different types, depending on the topography and other things to be considered. Thank you.
great, great. Very good definition. Thank you. Thank you very much. And you use it very good keywords. Okay. I will just write here and we can go to the next one. Okay. Agriculture, topography, and other and types. Great. So,
Hello.
Mohammed,
Hello.
please. Oh, yes, yes, please open. Mhm.
Hello, my name is Mohammed Ahad. Can you hear me?
Yeah, Mohammed, we cannot hear you very well. Maybe if you talk closer to your microphone.
Yeah, I said my name is Mohammed Ahad. Can you hear me now?
Okay, great,
So,
great. Mhm.
yeah, soil, in our own primary definition here, soil is defined as the topmost layer of the earth in which plants grow. Hello?
Okay. Mhm. Great, great. Hmm. Great, thank you very much. We also can catch some keywords. Layer of earth, it's quite important. Thank you very much.
Hello. Hello.
Yes, hello, welcome.
I'm democracy from Ethiopia.
Mhm.
Uh, in general, soil is a natural occurring unconsolidated materials. They are
Mhm.
composed of minerals. That is the origin of rocks.
Great, great
Yeah,
democracy.
yeah.
It's quite good.
From geotechnical perspective, soil is important for supporting the structures,
Mhm.
for safely loads in the ground, and the various behaviors depending on the classifications and
I,
the classifications.
I see, I
Thank
see.
you. Thank
Yeah. Oh, thank you very much. It's something quite interesting you said, because you said that we have different definitions according to your perspective. If you are talking from engineer or from agronomist or from geographer, you can have different definitions. This is quite important. Thank you very much, very much. We also have two people with the raised hands, Mohamed Yahaya and Sanel. Please, one of you can just open the microphone.
Thanks so much, Prof. Can you hear me?
Yes, perfectly.
Oh, okay, great. My definition of soil is that it is the thin, loose layer of material where
Mhm.
crops or plants grow, and it's a complex mixture of mineral particles, organic matter, air, water.
Great. You use it very good keywords. You all use it very good keywords, and we are having something that's quite similar between these concepts. Quite good. Thank you very much. And the last one, Mohammed, can you open your microphone? Oh, I think that maybe you forget your microphone, your raised hand. Okay, don't worry, don't worry.
He has already
Let
spoken, son. He has already said something. He was the one that
Oh,
spoke
yeah.
earlier.
Yeah, yeah. Guys, I have a very bad memory. You can realize that now. So please help me with that. Okay. Thank you. Thank you very much. Yes, you just will see in the next classes. Okay. So we bring some very good keywords like a layer that covers Earth, a thin layer with unconsolidated materials and loose materials. They can host, they can support life and plant growing. They can produce food. They are composed by mineral particles and organic matter. They are produced by weathering of rocks, but they also depends on topography. They can describe it in different types according the formation of each soil. They have a straight relation with agriculture, and these are the main keywords that I took notes here according what you said. And yes, it's 100% correct according to the definition of soil. And now I will bring some of my keywords and then we can move to the definition of soil taxonomy. Okay? I have a lot of keywords too. So, first of all, we need to know, we need to consider that soil has at least four dimensions. And what I want to say with four dimensions, because we have three physical dimensions and we have also time, because the soils can change through time. If I took a sample in 10 years ago and now in the same place, hardly we have the same properties, hardly we have the same characteristics, sometimes even a different type of soil, especially if the land use change it. For example, in the past I have a dense vegetation cover, a dense rainforest, and now I have agriculture. Probably some of these properties, characteristics, and maybe even some the soil type could change. So we need to consider this. And of course, not only according to soil, to the time, I'm sorry, but soil also can change in deep according to the depth or in the two dimensions. If I walk from the left to the right, if I go up or if I go down, all these properties will be changed according to these variations, the geographic variations and also time. Okay. Soil also is a triphasic body. It has three phases: the liquid, gas, and solid particles. So we always need to consider this because especially some soils related to climatic conditions like the reedy soils in the soil taxonomy and the jelly soils in the soil taxonomy, they have a straight relation with water and gas. So we need to consider this. And of course, especially for agriculture, this is quite important. This is a big deal for them because they need water and they also need some gases to produce food, litter, or anything. Okay? As someone said, soil it's composed by mineral particles. This is quite important. Actually, the majority of soils they have much more mineral particles than organic particles. These mineral particles can be defined as 2-to-1 minerals, 1-to-1 minerals, primary, secondary minerals, minerals with very high specific surface or very low specific surface. And this is quite important because the minerals, the composition of the minerals in the soil tells you about some process and stage of weathering, stage of leaching, and how chemically rich or poor that soil is. So let's say, for example, in Brazil, it's quite common to find soils rich in kaolinite and hematite and goethite and sometimes gibbsite. All these minerals express a deep weathering and a deep leaching. So if I want to produce food in this kind of soil, I need to know that these minerals cannot host a lot of chemical elements. They cannot host a lot of nutrients that are important to plant growing. So I need to add some fertilizers. I need to add something to improve the plant growing, the food production. But also, I need to know, for example, if I'm working to preserve a forest, I need to understand that a lot of the nutrients that feeds the trees and keeps the biodiversity high depends on the litter. So the litter is produced by the forest and the litter feeds the forest. So we have a closed cycle of nutrients biocycling there that keeps the forest up, the forest alive. Okay, so this is quite important. I will focus a lot on the mineral particles in the next classes. And of course, if you don't have a deep experience with that, don't worry, okay? Don't freak out. I will share some books and articles, and you can read and you can understand better. And even better, if you want to do something like, oh, JJ, I would like to learn even more about this, I can share individually some material to you, and you can understand even better, and you can improve your knowledge about these mineral particles. Okay, this is quite important. They also express some specific process, as I said. For example, if I find a soil in an area without goethite, without hematite, and that soil has a gray color, what means that that specific soil suffered in the past or in the present some redox conditions, some flooding conditions that induce the destruction or avoid the formation of iron oxides. And because of this, I cannot find goethite or hematite. So I need to understand that that specific soil suffered in the past or it's suffering right now, this kind of process, and this influence the kind of type of land use that I can plant, but also influence the native vegetation cover in that area. So everything is connected, considering the mineral particles, the mineral elements, the minerals that compose soil. Okay, but also happily, soil is formed also by organic particles. These organic particles, they are quite important, especially to deeply weathered soils, because the organic particles, we can talk about this in the next classes, they have a very high specific surface, and they can also host and be a source of nutrients. So they can absorb nutrients and release them to the plants when the plants need them, especially carbon, phosphorus, and nitrogen. So these three nutrients, they are really important to plant growing, native or planted vegetable cover. It's quite important to consider that the organic particles are really important. To some specific regions, for example, dry lands, the organic particles also are really important. Why? Because the organic particles, the majority of them, okay, it's not something universal, but the majority of them can absorb a lot of water and can release this water in dry seasons. So especially in dry lands, it's quite important to have a higher organic content in the soil, because then plants can absorb some of this water that it's kept by the organic particles, and the drought stress will be a little lower than a soil with a very low organic carbon content. We'll talk about this in the next classes, okay? So don't worry. Also, the soil express different states of wafering and the composition of organic particles and wafering of the mineral particles. So we can have soils that are rich in feldspars, microcline, pyroxene, elite, smectite, and we can also register some soils that are rich in gibbsite, kaolinite, hematite. So they express different stages of wafering. And this is quite interesting because express how the soil is formed, how the soil was formed, which process acted in the past and in the present, forming that specific soil. So this is quite important. And also the composition of the organic matter tells you about which process formed the organic phase of that specific soil. So, okay, JJ, I have an organic matter that's quite fresh. So means that the decomposition process are quite unusual, quite incipient, quite low. And we need to understand why. You can have some lab analysis and even some field analysis that can tells you why that organic matter is quite fresh or deeply wafted, deeply decomposed. You can have both. So this is quite interesting. Okay. One word that's quite important to define soil is pads. We need to register pads or aggregates. Without pads, without aggregates, we don't have soil. The pads, they are really important, especially to differentiate, for example, sediments and soils. The sediments, they have the same keywords that we can use to soil, for example, unconsolidated material, a layer that covers Earth's materials that are formed by rock wafering, but the sediments, they don't have pads. Sediments are produced by erosion, by mass movement from one area to another area, from upper lands to lowlands, or by runoff. But the soil can also move, no problem. But the most important thing that can differentiate sediments and soils is that the soils, they have pads. They really need this. And what are pads, JJ? I don't know very well. Well, pads are those groups of particles. Mineral and organic particles are getting together and composing that material that I can easily pick up and see in my hands. Some of these pads, some of these aggregates are huge. Some of them are larger than my hand, but some of them are really, really small. And maybe I need a microscope to see them better because my eyes are not really good. So pads are formed by soil formation. And the soil formation, it's a general and a broad process that express how soil is formed. But the first step is the pedalization, the formation of pads, when mineral and organic particles are getting together, when they are composing these groups. Okay, some of these pads can be hardly broken. Some of these pads can be easily broken. We will describe this when we start the soil description. But much more important than this, it's considered that at least we need to see these pads. Without pads, we don't have soils. Okay, We'll talk about this more, especially in the some classes related to soil description. Okay. Also, something that's quite important, it's considered that soils are formed by horizons and or layers, okay? And they are not the same. They are not the same. Horizons and layers, they have different definitions. But let's do this in the next slides, okay? For now, just consider, for example, as you can see in this picture, that we have here a section of soil with a darker color, here a section with a lighter color, and then here something that has a yellowish. Here we have the same yellowish color, but we also can see some red and dark models, okay, dark spots. So we have at least four sections. And some of the sections can be horizons or layers. So we need to consider that soil, it varies according to depth, not only considering the soil properties, the soil characteristics, for example, the clay content, the organic matter content, but we also need to consider that everything changes because we have different process acting in different depths. For example, this specific section of the soil has a lighter color because the process that create this specific section induce an intense leaching of clay, an intense remotion of clay. So clay was removed from this specific section and it's concentrated in this yellowish sections. Because of the intense removal of clay, this section has now a light color. Why? Because clay, it's something that really puts color in the soil. Without clay, we don't have a strong color. Because without clay, what can get the color in the soil? Basically, the sand and silt particles. And both these particles, they in general don't have a color. But because of the diffraction of light, we see a white color. So it's because we don't have a lot of clays here, organic and mineral clays. Because of this, you can see this white color. But this white color is related to an intense, deep removal of clay from this section. And these dark spots, they are related to iron concentration, because iron change from iron 2 to iron 3 in this specific soil and form it and create these models, these spots with darker color, darker than the surrounding at least. Okay, so each of these layers or horizons, they have different properties and characteristics because they are formed by specific process that we will talk in the next classes. And this is something that only occurs in soils. The sediments, they also have variation according to depth. Yes, but that variation depends only to the erosion or the concentration of material. For example, a fluvial deposit has clay-rich or clay-poor layers according to the sedimentation by the river. Okay, I think that someone raised their hand. Okay, yes, please, Amir.
Sir, as you say about the soil color, can we ask that it gives a clue about the mineral composition? Like it gives any uh, different
Uh,
like different color, and it should be the
mhm.
different organic matters and different mineral compositions. Can we say that?
Yeah. But Amir, it's something that's hard to do because, of course, if, for example, in this, like here, if you see this yellowish color, You can say, oh, probably you have some iron oxides, goethite. If you have this reddish color, probably you have hematite. Yes, you can do that. But you need to be careful because other horizons and other minerals, they have the same color. And sometimes the minerals are different. So yes,
Okay.
you can do this, especially after do the soil description in the field, because the soil description helps you to understand much better the things. For example, some descriptions tells you if that specific horizon has high or low activity clays. This helps you.
Okay.
Okay, so yes,
Okay.
you can have some groups, let's say in this way, but it's quite hard and imprecise to say only according to the color that, okay, I have this specific mineral. We run some specific analysis due to that. We run the XRD analysis or some microscope analysis to really classify and define which minerals we have. Okay?
Okay, sir. Thank you. And
Welcome, welcome. And oh, guys, please feel free every time to raise your hand and to ask me. Okay, it's quite important to do that. So I really feel that you are learning and we are talking. Okay, so please feel free to raise your hand and ask a question. Yes, someone also raise it. Yes, please, Marvelous. Go ahead.
Oh, okay, all right. Thank you so much for the teaching so far. I really appreciate. Actually, you made mention of some types of soil. If I heard you well, you. So I just want the clarity on that. You're talking about vermicolites, and I've forgotten the other one. And sometimes ago, let me say, I just got thought about the clay and other type of soil that actually came to existence through the action of volcanic eruption, precisely maybe vermiculite or something. So I was just I was just want before I actually wanted to ask it at the end of the lecture, but I might have forgotten actually. So it's best to ask now. So I would just want to ask about that vermiculite precisely now. Is it a kind of a pseudo soil or something, not a original type of soil? Does it comes from because I was told by someone then that it comes from eruption. I mean volcanic eruption, something that it's later effect of that, give rise to this. So I just want to ask, is it a type of soil? Can we really call it a soil? Because you also make mention of vermiculates. So thank you.
Oh, yes, yes. Thank you. Thank you very much for the question. This is quite interesting because we will see in our course about them. They are called endosols. And these endosols, they have specific horizons and layers formed by ash. Yes, we have a specific type of soil because we have specific minerals like allophane and immogolite that provides some specific properties. So this soil is quite interesting. It's quite important, especially for some regions, especially in Asia. We have a lot of them in Asia. Yes, we have some specific soils with these properties, and it's quite easy, let's say in this way, easy to identify them in the field. And the process that create the soils is also easy to identify in the field if you have the right tools, let's say in this way. Okay, if you have the right tools, you can easily identify them in the field and confirm their existence and the process that create that soil using some lab analysis. We also have some lab analysis that confirm the existence of these endosols. They are present in both systems, WRB and soil taxonomy. So yes, they are really, really interesting and important. We will see and talk about them deeply after some, I think that's 6 or 5 classes, because it's after I start to talk about soil formation and soil description, then we will start about soil classification, truly soil classification, and I will start to talk about that. Okay, but yes, great. It's quite interesting, the soils. I love them. I saw them in Japan last year, and wow, it's amazing. It's amazing. I really, really love them. So let's return. Oh, the last keywords that I add for soils is that, guys, it's quite interesting to consider that soils can be fluid or not. Because, of course, the majority of soils that we usually describe and use in our studies or use for agriculture, they are not fluid. But for example, we have rice and we have a lot of fluvial plains and we have a lot of fluid soils. And these soils, they are soils. They should be studied, they should be described, they should be classified. Why people doesn't like them very much? Because it's quite hard to work with them. It's quite hard to dig a soil profile. Now dig a soil profile in a flooded area. It's even worse because now you have water and maybe some insects and maybe even worse than that. So it's quite hard to work in these areas, but it's something that we need to do because we need to consider that these soils, for example, they can stock carbon. And we only can measure how much carbon it's stocked if we study these soils. We need to consider how much nutrients these soils have, or how many or how much or which have metals are concentrated in the soils. We can have some fluid soils with a high content of arsenic, lead, and other have metals. So it depends on which area and topic you work in the soil science. These fluid soils, they are really, really important. Okay. So let's go now for, oh, yes, someone raise it. Yes, please, democracy,
Yeah.
go ahead.
Okay, thank you. Whether the soil is flooded or not depends on the water content and the groundwater conditions.
Yep.
In the geotechnical engineering, we talk about this degree of saturation of soil.
Yep.
Soil and the floodings, depends on dry soil, saturated, unsaturated conditions like this.
Mm-hmm.
Thank you.
Oh, thank you. Thank you very much. Yes. We have some regions that the water table level can vary a lot according to the season. And even some soils, they have some perched water table. So the water table, it's even closer than this to the surface. And because of, for example, torrential rainfalls, you can register the flooding of soils. So this is quite interesting because we have some morphological, physical, and chemical properties that express those characteristics. But even more important than this, we need to consider that that specific soil, it needs specific planning for land use, and then we can really consider that soil in our plans in our area. So yes, this is quite important. So guys, here I bring the definition of soil according to soil taxonomy. So we can see that all our keywords are here. Okay, let's write very, very deeply. Soil is a natural body comprised of solids, mineral and organic matter, liquid and gases that occur on the land surface, occupies space, and is characterized by one or both of the following: horizons, layers that are distinguishable from the initial material as a result of additions, losses, transfers, and transformations of energy and matter are the ability to support rooted plants in a natural environment. So we consider that first, soil is a natural body. So in this specific case, in this specific definition, we don't consider that humans create soil. I hope that this definition change in the next few years. And why I'm saying that? Because for now, we don't have a soil order to soils produced by humans. But the soil taxonomy, they are testing the artisols. The artisols are those soils created by humans. And they are doing field work, they are classifying some soils, they are defining criteria to identify this specific soil. If everything runs good, if everything goes well, so maybe they will change this and consider that soil is a natural body, but also can be produced by, can be deeply changed by humans. Okay? In the WRB system, it's quite different because in the WRB, we have two specific groups. We have the technosols and we have the anthrosols, soils produced by humans. But as I said, in WRB, in the soil taxonomy, we still are testing these soils, considering that yes, they exist, but how can we easily define and we can easily identify and classify them in the field? Okay, so they are improving this, and I hope that this will change in the next years. Maybe in the next year, maybe in the next 2 years, I don't know. They still are testing this, okay? And as I said, they are comprised by solids, liquid, and gas. Of course, occupies space, change according to horizons and layers, suffer additions, lose, transfer, and transformation of energy and matter. And the last, the ability to support life. This last part of the definition, the ability to support rooted plants in a natural environment, was the initial definition of soil in the past. In the past, soils are defined as as a material, a loose material that can support life. But now we also consider that soils cannot support life in some conditions. For example, I can register a soil with a very, very high content of heavy metals, like arsenic. Oh, this soil still is a soil, but cannot support life. If I go to Antarctica, in some regions, I cannot find organic carbon. In some regions, I cannot find life growing in soil, even microbiological life, microbial life. I cannot see organisms in that soil because it's too cold, it's too dry. So, as you can see in the soil taxonomy definition, it's one or the other. We can register material that suffered some process, and even without organisms, still is a soil. Or I can just see something that can support life, and because of this, we call it as soil, okay? This is quite interesting because expand some of the definition of soils. For example, I can talk about Martian soils or soils in the moon because they have horizons, they have layers, some of them suffered some process. It's quite interesting because on Mars, we can see some cryoturbation features that I will show you that we register in Antarctica or Arctic or Russia or Canada. So some specific process that create soils on Earth also create soils on Mars. And because of this, we saw and we say that yes, we have soils on Mars, we have soils on the moon, and maybe in the other planets too. Okay, this is quite interesting because expanded concept. It's a quite general concept about what soil is. Okay, and let's start to talk about master horizons and layers. Okay, this is according to soil taxonomy because the WRB uses different definitions of master horizons and layers. Okay, so please be careful with this. When you see these descriptions, first of all, check which definition, which system are you using, because this can change a lot. Okay, can change a lot. So first of all, let's describe what are horizons and what are layers, and then we will talk about the master horizons and layers. So first of all, layers and horizons. The horizons, they are produced by process that creates soils. Okay, so for example, bioturbation. Bioturbation is the mixing of organic and mineral particles by plants and animals. Especially termites, they can mix some particles. They can take some particles in very, very deep horizons and bring to the surface. And some wormholes and even the termites, they can ingest some particles and defecate them, and these action produce some pads, produce some aggregates. Okay, so this is just a description of a horizon, something that's produced by a process that creates soil, because we are creating pads, we are creating aggregates. So bioturbation, it's a process that creates soils, especially in the tropics. So because of this, soils that has some sections that were influenced, that was created by bioturbation, they are defined as horizons. Let give you another example. We talk about some layers that has this whitish color, this very, very light color. And I told you that this light color, it's related to clay migration, to clay removal. So clay is removed from this specific section. Because of this, this horizon has a light color or a yellowish, not a yellowish, a whitish color. Okay, this is also a process that creates soils. So because of this, this white section, it's a horizon. And if this specific section it's losing clay, someone should receive this clay. Let's think. If the clay is being removed from here according to the gravity, the clay should migrate from here to this specific section. So all clay that's removed from this whitish color section, it's concentrated in this zone, in this section. Because of this, this is also a horizon, because this process of clay migration creates pads, creates aggregates. This specific process creates soil and some specific soils that we will talk in the next classes. So the clay migration produces soil. The clay migration produces horizons. And then we have the definition of horizons, some sections of the soil that are produced by process that creates soils. Okay, only process that create soil can create horizons. Okay. And what are layers? Layers are sections of the soil that are not produced by soil formation process. They are produced by other process. For example, a very, very common layer that everybody knows, the R layer. This R layer express the rock, right? The fresh rock. And the fresh rock is formed by what? By the geological cycle, by, for example, the solidification of magma or lava. So these processes are not processes that create soils. These processes are geological processes, and they create rocks. So the R section, it's always a layer because it's a section of the soil produced by other process that does not create soil, process that are connected to other systems. For example, the geological cycle. Okay, so horizons are produced by process that creates soils. Layers are produced by other process. And you can ask me, oh, JJ, how can I know? How can I know if that specific process create or does not create soil? You need to study the process. There's no an easy answer for that. Okay, we have more than 30 soil formation process. 30. So we have a lot. Yes, I know we have a lot of process, and I will share a chapter of a book that's quite good and tells you and talks and describe each of these process. So my suggestion, if you don't understand a lot about this process, just read this chapter. It will help you a lot to understand much better what are horizons and layers. Okay? So let's move to the master horizons and layers now that we know the difference between horizons and layers. I will gave you more examples and will be even easier to understand the difference between them. Okay? So the first one is the O section. And you can see here in this picture, the O section is the organic section. And this section can be a horizon or a layer. So I can register organic material, organic rich section on the top of the soil, because in general, this section, it's at the top, but also can be close to the surface. Sometimes this organic layer is buried by another horizon by mass movements, okay? But in general, it's at the surface or close to the surface. And it's composed by organic matter. So the physical and chemical properties of this specific section, it's controlled, is determined by the organic material. Okay, so according to which type of organic matter I have in this section, will define the properties of this specific section. And why I said that this specific section can be defined as a horizon or a layer, because I can register some process that create horizons and create an organic rich horizon, or I also can find some layers that are composed by a lot of organic matter, but they were not produced by process that create soils. For example, in this specific photo, in this specific case, you can see a lot of leaves. So this, it's a litter that's just covering the soil surface. And this, a lot of litter, a lot of leaves are just produced by the trees. The leaves just are released and fall at the surface. Just that. It's just a biological process without any relation to soil formation. It's not, it cannot create pads or aggregates, for example. So this specific section that you can see in this picture, it's a layer. It's a O layer because it's just litter. It's just a lot of organic material that's concentrated or accumulated at the top of the soil, of the mineral soil. So just an organic layer. But let's think, I think that I have, oh, no, I forgot to add. I can add later, don't worry. Let's think about a section that we have a lot of organic matter, but now in this case, this organic matter, it's composing pads and aggregates. So I can see some groups of organic and mineral particles inside the soil. In this case, I will call it as a O horizon. I forgot to add the picture, but I will do this in the next few slides and will be much easier to differentiate them. Okay, don't worry. So I can register a O layer or a O horizon. But in the both cases, the O is related to a very high organic carbon content. Okay, the minimum content of organic carbon to define a O horizon is 12%. So you can, of course, describe an O horizon or an O layer at the field, but you must run some lab analysis to confirm, to be sure that you are talking about, you sampled, you described a O horizon or a layer. You need to measure how much organic carbon, and just organic carbon, the mineral, it's not considered, just organic carbon. And if this amount it's at least 12%, so yes, you have an organic layer or an organic horizon. If the content it's less than 12%, I'm truly sorry, you need to change it to a horizon. And what is the A horizon? The A horizon is a dark section of the soil, but the organic carbon content is not quite high. Like in general, I can register 0.6% of organic carbon, 1%, 2%, 3%, in some cases 5%. But the most common range is between 0.4, 0.2, and 1.2%. Between 0.2 and 1.2, okay, percent of organic carbon. It's the majority of A horizons. So you can see that the organic carbon content it's much lower than the organic carbon in the horizons and layers that are defined as O horizons or layers. So in this case, the A horizon, the properties are influenced by the organic carbon, but the properties and characteristics are not defined by them. They are defined by the minerals, which kind of minerals I have in this specific section. So yes, it defines the properties. If I have high or low organic or carbon, of course, it influences, but the high activities or low activity clays, this will determine the properties of the A horizon. And the A horizon, it has a low organic carbon content, or at least lower than the O horizons and layers, but it registers a dark color. And why it has this specific dark color? Because of partial decomposition of the organic matter. So the partial decomposition of organic matter induce what we call as melanization. the melanization produce this dark color because we have a darkening of this material because of the partial decomposition, getting this dark color, and then we can see the influence of the surface process, like roots growing, partial decomposition of material, some bioturbation that forms the A. And A, it's always horizons. We don't have A layers because demelanization, it's a process that creates soils. So melanization creates the A horizons, and because of this, we always call them as A horizons. We don't call them as A layers. Doesn't make sense. Okay? We also have the E horizons, and these E horizons, as you can see here, they register the removal of clays or the destruction of clays. And when I say clays in this specific time, I'm talking about mineral and organic clays. In both cases, the E horizon, it's losing this material, okay? The clay can be migrating. You can lose clay because the clay is migrating from this specific section to this section according to the gravity, or I can just register an intense destruction of clays because of very acidic pH, okay? In some specific regions, especially in the very wet regions like Amazon rainforest, we can register a very acidic conditions, very low pH, and because of this, it could destroy clay and create a horizon with a very high sand and silt contents. And because of this horizon gets a whitish color. So this process of clay migration or destruction of clay, both are process that creates soil. And because of this, the E horizon, it's always a horizon. We don't have E layer, okay? So the O, organic matter, a lot of organic matter. The A, the melanization, the darkening of a section of soil. The E, the whitening of the horizon. The horizon is getting a whiter color and much more sand and silt contents because it is losing clay, organic and or mineral clay. Okay. The B, it's always a horizon, and the B horizon, I know that everyone heard about a B horizon. The B horizon, it's basically that section of soil that receive clay or concentrate clay in a relative or absolute way. And how can I say that? For example, when the E horizon is losing clay and the B horizon is receiving the clay content increase because it's an absolute increasing of clay. I'm receiving clay. But also I can register a deep wafting. And because of deep wafting and leaching, the B horizon can concentrate clay because it concentrates clay, because the gravity just induced an intense wafting and destruction of clays here and here because of the very acidic pH because of the organic matter. And in this case, in the B horizon, the organic carbon, it's not too high, so the action of this intense acidity and destruction of clays are not so big. So I'm not losing clays as the A or E horizons, but I'm not producing or receiving clay. But there is a relative concentration of clay in this specific horizon, and then we call it as a B horizon. Another example of B horizons is just the formation of pads and aggregates. If I can register some color or some any morphological evidence of a intense soil formation process, yes, I will call it as a B horizon, okay? And it's much more easier to understand and define a B horizon when we compare it to the C horizon. The C horizon, it's a weakly wefted rock. So we call it in general as saprolite because we have some primary minerals, we have some structures that shows you that in this specific section, in the C section, in the C horizon, we have an incipient wafering. So we keep some register, we keep some evidence of the parent material. And I can talk about rocks because it's quite easy, but I also can see some fluvial and colluvial evidence of mass movement showing you that that specific soil was formed by wafering of alluvial deposits. So in the A, E, and B horizons, I cannot see any evidence of this fluvial deposits, but at the C horizon, I can see some lines, I can see some bands, some material that shows the organization of the particles and the sedimentation of clay, silt, and sand. So the sea horizons shows you which material was wafted and decomposed to create the horizons that you can see above. Okay, so it's why I said that's much easier to differentiate the B and C horizons, because if you compare them, the B horizon, of course, can host some of the particles, some of the structure of the parent material, but the amount, it's very, very low. I will talk about this amount in the next classes, especially when we start to talk about some specific B horizons. But for now, just consider that this amount should be very, very low. So it's not common to find a lot of rocks in the B horizon, because to create a B horizon, this rock should be destroyed, should be wafted. But it's quite common to find rocks in the sea horizon. It's quite common to see alluvial deposits in the sea horizon because the wafting there is not intense, at least not so intense as in the B horizon. Okay, so B, it's always a horizon. The C can be a horizon or a layer. Wow, how can I differentiate now horizons and layers in the C section? In this specific section, you need to check if you already have pads. Do you have aggregates? Yes, JJ. So you should call it as a horizon. Oh, I cannot see any pads. I just see fresh rock that started to be wafted and some rock fragments and some layers of alluvial material, but no pads, no aggregates. In this case, I will call it as a C layer, okay? So the pads are the key to differentiate C horizons and C layers, okay? We also have the L horizon. It's a horizon, it's a section of material that concentrates limnic material, especially in lakes. We can see it very, very easily. So it's a material that's rich in organic matter or mineral materials, but basically deposit and concentrated in fluvial conditions, especially in lake areas that register a very calm system, a very calm system of deposition. Okay, I have some pictures I will show you, will be much easier to see. We also have the W layer, and in this case, the W came from water. So some soils can have the water table level. We can see it very, very easily. And when you see it, you call it as a W layer. And this layer, this section, also can host solid water. For example, if I visit Arctic or Antarctica, I can see the permafrost. And the permafrost is, in some cases, frozen water. In this case, I have the W layer. I have a layer that's quite rich in water. Okay. We also have the M layer, and the M layer, it's a layer produced by humans. It's quite interesting and strange, because at the same time that we consider that we have a layer produced by humans, we still don't consider that humans produce soil. Well, as I said, I hope that this change in the next years, but we have a horizon, sorry, a layer produced by humans. I will show you some pictures. Like concrete and rubber rich horizons or sections are the M layers. And as I said, the R layer, the fresh rock material that you can hardly broke with your hands, with your fingers, or even with light tools. You need heavy tools to broke on R layers. You cannot broke it using only some easy material that we usually use, like a shovel. You cannot broke an R layer with your shovel. Okay. So let's start to see, for example, the O horizon or the O layer. As I said, it's an organic section. Okay, a section that's quite rich in organic material. This material should not be limnic material, should not be an organic material that's concentrated in lakes. The process that induce this organic rich horizon, it's called paludization and littering. The paludization is a process that express concentration of organic matter in flooded areas. So for example, if you go to a mangrove, you can see a lot of organic matter there because you have flooded conditions, a lot of salt that helps, that yields, that induce a concentration of organic matter. So you can see a O horizon or a O layer produced by paludization. But we also can see the littering, as in this specific case, I'm seeing an area that is in a highland. This is quite high. The altitude is around 3,000 meters above the sea. So the climate conditions, it's quite cold and dry. And because of this, the microbiological activity, it's quite low. So basically all the organic matter that's produced hardly will be decomposed. And because of this, you concentrate organic matter and you can produce a thick layer with a lot of organic matter. So you can see here, at least from 0 to 50 centimeters, a very, very dark color. And between 50 and 100 centimeters, you have also a dark color, but it's like a less darker, let's say, than the surface. And something that's quite interesting in this picture, that you can see a lot of cracks, a lot of cracks. And it's quite common in the soil science that we saw these cracks and say, oh, high activity clays. In this case, these cracks are not related to high activity clays. In this specific case, these cracks are produced by the organic matter, because you know better than I, organic matter can absorb a lot of water. So just think about a grape and a dry grape. If you dry it, the change of volume, it's huge. And this change, it's only related to the amount of water that was in that grape. So the organic matter basically hosts a lot of water, can absorb a lot of water. And when you register, so for example, the rainy season and the dry season, this change of water, moisture in the air, this change of rainfall can induce that soil shrink a little bit. When you have a lot of organic carbon that absorb a lot of organic matter, that absorb a lot of water, this shrink can be very, very strong and intense, and then you can see these cracks. Okay, so we can see here a soil with a very high organic carbon content because of the color, because of the cracks. But also, if you go there and take a piece of the soil, you will realize that this soil is quite light. Why? Because we basically have material organic that is rich in carbon, and carbon, it's a quite light chemical element. So you can take a large piece of soil and the wave is basically nothing because you have a lot of carbon. It's different from taking a piece of soil in a soil that has a very low organic carbon content, because a soil that's rich in iron, aluminum, and silicon, they have elements that are dense, that register a very high density. So if I take a piece of soil that's rich in iron, yes, it's quite heavy, and it's much more heavy, it's heavier, and then this one that's rich in organic carbon. Okay, as I said before, this organic matter can register different stages of decomposition. So it can register very fresh organic material, material that's deeply weathered and decomposed. And also something that's quite interesting is that these O horizons and O layers, they can be saturated or not by water. So this one that you can see, it's a O horizon, but this one, it's also a O horizon. So you can see here a very dark color with a lot of organic matter, and you can see the water table here. And you cannot see this using this picture, but believe me, this water table achieves the surface. So this area, it's a flooded area in Brazil. And because of these flooded conditions, you induce a lot of organic carbon concentration, and you can see this very dark material that is a O horizon. So O horizons and O layers can be found in saturated waters, saturated areas, drained areas, or areas that never was drained. Okay, so I can find or O horizons or O layers everywhere. I just need to find an area that register a very high organic carbon concentration. And as I said, they can be found on the surface. The majority of them are at the surface, but some of them are buried. Okay, some mass movements can bury the organic layers, the O layers, the O horizons. Okay, for example, think on this specific case. Because of this water, you can imagine that we are very close to a river. So we are in the lowlands, in the area, that specific watershed, it's the lowest altitude. And we can register some mass movements. So the mass movements can bring and add material that now can cover this specific section. So if, for example, some material just cover the soil, now the organic layer is not in the surface anymore. It's buried. So it's not a problem. We consider that yes, we can find some old horizons and old layers buried by mineral materials, by other horizons, because something occurred in the past and buried this material. Okay, so let's go to the A horizons. And the A horizons, as I told you, they are horizons that the organic carbon content it's much more lower than the O horizons. So they have a dark color, but just because the partial decomposition of the organic matter. Actually, the mineral phase it's much more important in this A horizon. So in this case, I need to consider that this A horizon it's quite important because of course it's much more common than the O horizons and the O layers because the partial decomposition of the organic matter it's basically everywhere. We can see it everywhere. It doesn't depend on a very high organic carbon content. Even some very low organic carbon contents like 0.2%, 0.4% of organic carbon, it's enough to create a dark horizon at the surface, okay? And the A horizon, as it is little or a rock or no rock structure. So I cannot see a strong influence of the parent material in the A horizon. So yes, you can find some rock fragments, but not a lot. Okay, you cannot find a lot of evidence of the parent material on the A horizon. As I said, it suffered in the past and or in the present the melanization. So this dark color came from a partial decomposition of organic matter. And something that's quite important too is that the A horizon admits anthropic influence. So for example, this soil profile, you can see this very dark color, but also some of these white materials. What are these white materials, JJ? I can show you. They are shells and bones. This specific soil profile was described here in Brazil, and we analyzed soil and described it and defined it that this specific soil was produced by humans. All these shells and bones, they were added in the past by humans in this specific zone. So all this dark layer with more than 150 centimeters is just a material produced by humans. I cannot find this in natural or non-disturbed areas. So we call this as a horizon to sections that were influenced or deeply influenced by humans, by movement of material by machines, by addition of fertilizers, by addition of organic material, by ancient communities. Everything is human action and everything will create an A horizon. Okay? We also have the definition of A horizons related to some superficial process. So for example, horizons that suffer with a lot of runoff and soil erosion, especially clay and organic material, creates some sections at the surface with a very high sand content and also in sometimes a gravel content quite high because we have an intense superficial erosion In this case, we also create an A horizon. So any kind of superficial process also can create A horizons, even if the dark color is not present. Okay, even if there's no influence of humans. And as in the case of the A horizon, in the O horizon, I'm sorry, the A horizon also can be at the surface or buried. So I can find it. Of course, the majority of the cases are at the surface, but as in the other case, some mass movements can bury some A horizons, and I can find them at deeper sections. Okay, I will show you some pictures in the next slides that show a horizon that's buried. Okay. Okay, guys, it's for me. It's 10:35. Maybe we can stop for 10 minutes, and I can drink some coffee and water, go to the restroom. Let's return in 10:45. Okay? 10 minutes to rest a little bit.
Okay.
Okay. Thank you. Thank you.
Okay, sir.
Okay. Am I the only one? I'm not seeing a picture anymore now.
You are not seeing which picture? The slides? This one?
Yeah, the slide. Yeah,
Oh, okay.
it's not
Okay.
viewing.
We're on a recess for 10 minutes.
Okay.
Yes.
All right, let's wait for the 10 minutes. Thank you. The lecture is impressive.
Oh, thank you. Thank you very much.
All right, thank you.
So, hello everyone. Let's return. Just drink a little of coffee. Um, let's return. Great. Let's talk about the E horizon. As I told you, yeah, before, the E horizon express the losing of clay, organic and mineral clay. Okay, so what we call as alluviation, it's just the migration of clay according to gravity. So think about this white section. It's beautiful, right? Seems like someone painted this. Seems like art because it's amazing. I love this variance of white, dark colors. It's really, really interesting. And this white section, it's white because, as I said, it loses some clay, organic and mineral clay, and because of this, it's just reflecting the light, diffracting the light, the sunlight, and we can see it as a white color, a very strong white color, because the organic matter, the soil organic matter, was alluviated, migrate according to the gravity, according to the water penetration through the soil that migrates through the voids and can carry some organic, some soil organic matter, and some also minerals, especially clay, because clay, it's really, really thin, it's really, really small, it's really, really light. And because of this, we have an intense remotion, an intense removal of material, fine material from one section, and creates this white color, okay? White and sandy and silt materials. So if I use my knife and took a little of material in this section, you will feel like a sandy texture or some silt, okay? This section is basically composed by quartz and sometimes feldspars, but basically 100%, not 100, 99% of the cases is just quartz, okay? And then you can think about the soil fertility in this specific section. It's quite low. It's basically nothing. You don't have nutrients, you don't have water, you don't have nothing. So it's beautiful, but it's quite poor. It's not a horizon that has or host nutrients and water because you don't have clay. And then you create this E horizon. You also cannot find a lot of rock structure, so you will not see any kind of stratification of materials because of alluvial or colluvial deposit, and you cannot see a lot of gravels or rock fragments because it's a horizon that express an intense alluviation, or as I also like to say, migration of clay. Okay, the alluviation is just a fancy word for this migration of clay. And some E horizons I forgot to mention in this slide. Some E horizons also are produced by clay destruction. Do you remember? I told you that in some specific zones, especially in areas that you have a lot of rainfall, I really love to express the effect of the rainfall in these areas because, for example, in some regions in the Amazon rainforest, we have precipitation around 3,000, 4,000 of millimeters per year. It's like a lot of water. And this water destroy the clay because you have a lot of acidity, especially because the biological activity, you have a lot of plants and these plants produce litter. This litter, it's partially decomposed by microbiological activity that produce acid, and this acid destroy clay and can produce some zones with this white color because it is destroying basically everything. Kaolinite, hematite, goethite, everything, all the clays that you know, they can be easily destroyed because the pH is quite acidic. Okay, but you also can find these horizons also in some temperate zones. For example, coniferous forests, they also produce a litter that's quite hard to be decomposed. And when this litter is decomposed, also produce a high amount of acidity that also destroy the clay and produce the E horizon. So the E horizon is not really common. You can see it in some areas, but it's not like really common. But it's quite important. If you see an E horizon, yes, pay attention to it because it is telling you that the process that occurs in that specific zone are even more complex than in the surrounding area. Okay, I really like this E horizon. And we have the B horizon. As I told you, the B horizon, it's a little complex to define it because basically we have a lot of keywords related to B horizon. The B horizon can express the eluviation. So we have here the eluviation, the migration of clay, and here we have the eluviation, also the migration of clay. But we use these words for different perspectives. The eluviation with the E we use to express that specific section, it's losing material. So the clay is migrating from here, this white zone, to this darker zone. So we express the eluviation. But when we use the eluviation with I, we are talking about, or we are focused on the zone that's receiving the clay, receiving the material. So in this specific case, we have a horizon that's receiving the clay. Again, here we have an E horizon. You can see the white color is not so white like the previous slide, but you can see the white color. And here a very strong reddish color, like blood. It's really interesting and beautiful. This zone below, it's a B horizon. Why? Because this section received all the clay that migrates from here to here. So it suffered what we call the eluviation with I, the migration and concentration of clay, okay? And also we can see in this picture the same, here the E horizon and here the B horizon. But in this case, it's quite interesting because this B horizon has a dark color, because now we can see that in this specific case, what migrated was the organic carbon, the organic matter. The organic matter migrate from here to here and concentrated in this zone, forming a very dark color, but it's a B horizon because this material was not formed at the surface. This material migrated from one horizon to another. And now can pop up a very interesting and good question. You can think, JJ, okay, I believe you that this material migrate, and because of this, this is a B horizon. But how can I know in the field, if I see this kind of thing, that this is a buried A horizon or should be a B horizon? How can I know that this specific dark color is formed to a buried horizon, or no, it was formed by migration of clay? Well, as I said, this is a very good and interesting question, but we don't have just one answer for it, because you need to consider each case. And we have some field analysis that you can do and can provide the answer. But the majority of answers, the majority of analysis that you can find, you really run some lab analysis, okay, to provide, yes, I'm seeing something that suffer migration, or no, I'm seeing something that was buried, was formed at the surface in the past, and then it was buried by some mass movement. Okay, I will talk about this in the next classes, because I need to provide a very precious definition about what we call lithic discontinuity. And when we talk about this, I will show you some lab and some field analysis that you can run and you need to run to identify if that specific horizon is a buried A horizon, or it is just a B horizon, something that was formed at the surface or something that was formed at the subsurface, okay? But for now, let's just keep this for this next classes, because it's too much information, okay? And I need to be sure that you understand, first of all, what is a B horizon and what is a horizon. Then we can deeply go to this analysis, okay? So for now, just keep this question. I will answer it in the next classes, okay? And as I said, it's a very interesting question and very important question. When you go to field and see this kind of things, like a very dark horizon at the subsurface, I usually say that you won the lottery, because you find something that it's quite interesting to know. And it's why we are doing science, right? We are doing science to find something interesting. And wow, this is quite interesting, okay? So in both cases, this reddish and this darkish horizons, both are B horizons, because both concentrated something that migrate from upper horizons to this specific section, okay? The B horizon also can concentrate material by residual weathering, okay? So, for example, in this specific soil, I'm quite sure that some of you guys can see some of these soils in your home country, because this is a very deep weathered soil in tropical conditions. We call it ferrosol or oxysoil, depending on the system that we are working on. And this specific zone, very, very fixed on between 30 and more than 200 centimeters, it's a very deeply weathered zone, which minerals are basically goethite, not in this case, but sometimes hematite and kaolinite. The sand fraction is basically quartz, because all the primary minerals were destroyed by the intense weathering and leaching. And because of this intense weathering and leaching, you cannot produce any 2-to-1 minerals. You cannot produce elite or smectite or montmorillonite, just basic minerals, because you don't have a lot of silicon and aluminum and potassium or calcium. The pH is quite acidic. The conditions, they don't allow formation of 2-to-1 minerals. So you concentrate clay, you concentrate some clay minerals, but basically those that are quite resistant against weathering. This also is a definition of B horizon. And because of this, we call this section as a B horizon. Okay, of course, you cannot see a lot of rock fragments here or any kind of stratification. It's quite hard to say the parent material that formed this specific soil because we cannot see anything, any evidence of the parent material. This is a very good definition of B horizons. Okay, the B horizons also can suffer some removal, addition, transformation of carbonates, gypsum, or salts. So, for example, this horizon, it's amazing, guys, it's amazing. I have some soil at my hand, and you can see some soil here and some pebbles and some particles of sand, clay, and silt, but you can see that everything is cemented by something with a white color. In this case, this white color, it's carbonate. In this specific case, I was describing a soil profile which suffered carbonates migration. In this case, what? Yes, the carbonates migrate from the surface horizon to the deeper horizons, and when these carbonates migrate with water, starts to precipitate and cement that specific section and created a cemented section by carbonates. So all soil, all horizon that was formed before the cementation is there. You can see all the particles, but now all voids, all the pores that you had in the past are fulfilled by carbonates, calcium carbonates in this specific case. This is also a B horizon, something that suffered removal, addition, transformation of some minerals that easily can be destroyed, like carbonates, gypsum, or salts. Yes, this will be defined as a B horizon. I will show you some examples in the next classes, okay? And very beautiful pictures. Yes, if you register just the pedalization, the formation of pads, formation of aggregates, it's also enough to register to identify a B horizon. Here you can see a micro photograph that we took in a microscope, and you can see in this white zones the voids, and between the voids, of course, the pads, the aggregates. And you can easily see here where I'm showing the pointer that this material is a group of particles. So because of shrinking and swelling of the soil, you create some cracks. And because of these cracks, you just put the soil together, all the particles together, and they are creating and forming pads, aggregates. If I can see pads, if I can see aggregates, and I don't have a very dark color because of the organic matter that was formed at the surface, if I don't have a very white color and sandy texture, it's not an E horizon. In this case, I will have a B horizon, okay? Something that's also quite interesting, and it's quite common in B horizons are clay skins. The clay skins, some pressure and some friction faces are these shiny faces that you can see here. I know on the computer it's not the best way to see clay skins. You can see this very, very easily at the field, but in the computer, on the slides, are definitely not the best option. But I will try, okay? I will try to do my best. I hope you can see a shiny face here, okay? Showing that in this case, this specific pad, this specific aggregate is covered by a lot, some millions of clay particles. And because of this, this clay particles acts like a mirror. that reflects the light, the sunlight. Okay, so think like you can have a mirror that the sunlight reflects and go to your face, and because of this, you can see a lot of shiny faces or shine faces on the mirror, depending on the way that you move your mirror. But now think the same, like I have some millions of particles, and these particles, they have a flat shape, and they are on the surface. They are covering the surface of this specific pad, and they reflect the light because they have a flat shape. And because of this, you can see this shiny face. I will explain better this specific process, how these clay skins are formed in the next slides, and no, in the next classes, I'm sorry. But we don't have time to talk about it right now. I prefer to do this in the next classes, okay? The same for, oh, I forgot, I didn't show you the pressure and friction faces, but it's quite similar to this. I will show you in the next few slides, okay? Also, some reduximorphic features. So you can see the blue color. I hope that everyone can see the blue color in this specific section. This blue color should be only gray, but this color, it's related to what we call reduximorphic features. Features that are produced by the water table fluctuation. Because of the water table fluctuation, you change the redox and oxic states, and then for example, iron 3 in the iron oxides in goethite and hematite can be reduced to iron 2, and because of this iron 2 cannot support the structure of goethite and hematite. These minerals are destroyed, and you now don't have any yellowish or reddish color related to iron oxides. And because of this, the soil has a section with a gray color. This gray color comes from the mix of materials with a white color, like kaolinite, quartz, and materials with a dark color, like the soil organic matter. If you mix white and black, you have a gray color, and it's what you can see in some of these soils. In some cases, these reduximorphic features are so strong that you can see this blue color. It's like, wow, blue, it's strange. But yes, you can see them. They are amazing, okay? Also, a B horizon, wow. And something that's quite important to let you know, it's that the B horizon, it's always formed at subsurface. Okay, always, always. Oh, JJ, but I found a soil close to my home, and this specific soil, it has a lot of clay skins. So I can see some shiny faces, and so according to what you said, it's a B horizon, but these shiny faces are at the surface. So it was formed at surface. No, I'm sorry. It not was formed at surface. It was formed at subsurface, and some intense erosion occurred in the past, removed, for example, the A horizon, and now the B, it's exposed. The B, it's at the surface, but the B is never formed at the surface, okay? It's always formed by subsurface process. So it's something important to consider when you are describing and classifying soils. The C horizon and layer, as I told you, they register a weak wafting and a weak leaching. You can see a lot of primary minerals, you can see some rocks, you can see some evidence of the parent material, and it doesn't register any property related to O, organic matter, to A, melanization, to E, eluviation, or to B, any of those that we mentioned. Okay, so the sea horizon, it's also a subsurface horizon that express a weak wafting of the parent material, a weak obliteration, destruction of the parent material that form that soil. And we exclude the sea horizons and the sea layers from those sections that register any kind of cementation, okay? So any cementation I will connect with the B horizon, not with the C. I can show you here some pictures. For example, here is a nice that it's quite easy to broke. I can use even a knife or even my hand to broke some of these parts. It's a sea horizon, definitely a sea horizon. Here I can see also a sea horizon, and in the shallow, in the deepest layers, the R starts to show, but all this zone I can easily broke with my knife or a shovel. It's why I call a sea horizon or a sea layer, depending on if I can find pad or aggregates. Okay, this is just a photo of old, very old and ancient field work, just to show this material. The W layer, as I told you, it's related to water. So if I can find the water table, like here, yes, you find the W layer. Okay, it could be inside or covering the soil, no problem. As I told you, it could be liquid or solid. As I know that the picture is not the best one, but it's one of my pictures. You can see here, like a blue color. Okay, this zone is solid water. It's the permafrost. So this is the W, and then we use the F. So WF layer in this specific case because it is solid water. We also can see the L horizon or layer. This L horizon or layer express some material formed or concentrated in lacustrine or lakes in very calm conditions. So you can see, for example, in this zone, close to 40 centimeters, are darker color and very thin material. In this specific zone, we have an ancient lake condition that allowed concentration of very fine particles, very thin particles, and organic rich material that induced what we call as a L horizon or L layer. Again, the horizon and the layer depending on if I can see a pad or aggregates. If I can see aggregates, a horizon. I can't see any aggregates or I can't see any pad, it's a L layer. Okay, the process that create this horizontal layer is just the paludization, as I said, the concentration of organic materials in fluid environments, in fluid conditions, and it could register laminic and organic materials, can register mineral or organic materials. Both register, both fits the criteria to identify the L horizon or the L layer. Okay, I have a picture of that material. You can see some of this platy surfaces here showing that this material was deposited. And this picture is much better. Of course, it's not the same soil profile, okay? This photo I took in another area, very, very far from this first soil profile, but also show you some material was deposited. And it's quite easy to see even the layers of material. This very white color, this is strong white color, is related to precipitation salts and carbonates. So I have salts, carbonates, and some organic material inside and between the layers. Okay. The M layer, as I told you, it's that section that has some human influence, and something that's quite important, that this specific section avoid root growing. So this section should be a section produced by humans and at the same time root limiting subsurface layer, something that avoids root growing. So for example, in this case, people are just putting this kind of rubber to avoid water and liquid migration, but also some root growing in this area. In this case, we also have a soil here in the US with a lot of bricks, you can see, but also some concrete at 80 centimeters that could avoid some root growing. So you cannot see any roots growing below 80 centimeters. Because of this, we call it as an M layer. Okay. And the easiest is the R layer. The R layer is just that layer formed by fresh rock, or in this case, a cemented material, okay, but expressing the parent material. So in this case, it's not something that was cemented because, for example, carbonates migrated and concentrate there. No, 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 no. It's something that was formed in the past, and the wafting of this thing, cemented thing, is being released, it's being producing the soil, okay? You cannot broke our layer with a shovel, with your hands, with your knife. You need have power equipments. You need heavy equipments to broke them. So it's a very good way to distinguish, for example, between an R layer and a C layer. Can you broke the C layer with a shovel? Yes, easy. So if you can broke with a shovel, it's a C layer. If you cannot broke it, so it's a R layer. So now we have the distinguishing between all the master horizons. Let's start to talk about other interesting questions and interesting issues that we need to solve. First of all, as I told you, we have some buried horizons. In this picture, you can see a buried horizon. Here, between 30 and 40, 45 centimeters, in this darker zone, you can see a buried horizon. In this case, it was a horizon that was formed in the past and buried by mass movements, okay? As I told you, in the next classes, I will show which techniques, which analysis you should run to identify if you are looking at a horizon, a buried A horizon, or a B horizon that was formed at subsurface, okay? We also need to consider that we have in the soil taxonomy the definition of surface mantle of new soil material. In this case, we are talking about anything that it's above a buried horizon. So all this section between 0 and 30 centimeters, all this material, we call it as surface mantle of new soil material. This section is related to a material that was added by erosion, by mass movement, and it's why we call it as using this definition, okay, of surface mantle of new soil material. Of course, we can classify, we can describe, we can do everything here too, but we need to know that this material was added by soil erosion. It's not formed in situ, okay? And we use also the same for human transported materials. We use also the surface mantle of human transported materials. So, for example, let's say that in the past, this material, this A horizon was at the surface, but some humans decided, I don't know why, to bury this material. They bring materials from other areas and create a new surface. Okay, this is quite common in South America, especially for some indigenous people. In the past, they bring material from different regions to create larger and flat surface. They can so produce more food. So it's quite common. In this case, when we have humans bringing material from one area to another area, that material that they bring, we call it as surface mantle of human transported material. And we add a symbol for it to indicate that that specific section was transported, was added by humans. Okay? Something that also is quite important in the soil science is the use of apostrophe. Why, and when we should use this? The apostrophe should be used when you have more than one master horizon that's classified as the same way, but they are separated by another master horizon. So let me show you this picture. Okay, so we have here between 0 and 10 an A horizon. And then we have here a white color, E horizon. And then we have a darker color, a B horizon. And then a very dark color, another B horizon. So we can call it B1, B2. And below B2, you have again a whiter color. So here we call it as a E horizon again. So we have A, E, B1, B2, and E. But the E red was described here between, let's say, 10 and 20 centimeters. So in this case, I should add an apostrophe to E, should be E apostrophe, showing that I have an E horizon here, and I have a second E horizon here, but both are separated by a B horizon, actually two B horizons, B1 and B2. Okay, so I have A, E, B1, B2, and E apostrophe, because this second E is separated from the first one by a B horizon. This is quite common to find in some specific soils. We just use the apostrophe if this second horizon is separated from the first one. So, for example, you can see that here I just said B1 and B2. I don't use the apostrophe because both, they are together. They are close to each other. There's nothing between the two horizons, the two B horizons. So B1, B2, it's enough. But in the case of the E, in this specific case, I really need to use the apostrophe, okay? And also, something that's quite common, you will see in all articles and books, is the use of suffixes. The suffixes, they provide a better characterization of that horizon or layer that you are describing. Okay, so we have a lot, like a lot of suffixes that describe the properties of the soils. And these suffixes, they are being designated at the field, but also some lab analysis can provide the information needed to add the suffixes. And they are really important because they provide available information to precious information to the soil classification, okay? We will see these suffixes in the next classes, because I know that it's a lot. And when I mean a lot, I really want to say it's a lot. And maybe will be more interesting to stop here because we already talked about a lot of things. So we'll give you some time to rest, solidificate the material that we talk, and also I will share the material about these suffixes, and I will ask you all to read it. Okay, so in the next class we can discuss more about the suffixes, and will be much better than just I told them what they mean. Okay, I know someone raised it. Nope, no. Okay. Oh, someone just writes something. Yeah, definitely, guys. Don't worry about. I know that we have different backgrounds, so I will try to share all the information that you need, even if you never you never studied about soil. Okay, and please, if you need more information, if you need more material, you need more references, just let me know, and I can share the information with you all. Okay, please, Kolo, go ahead.
Yes. Would you post the slides of the lecture on the PVR module?
Yes, definitely. I will do that.
Oh,
I will do better. I will do on Google Drive because people that are not UFE students, they cannot access PVA. Okay?
okay.
Okay, but I will send the link for everyone. Don't worry. Don't worry.
Okay, thank you so much.
Okay? Najib,
Yeah, good morning, my professor.
good morning.
Yes. I just want to confirm if the physical class is going to hold for this particular course this semester.
Yeah. I just selected to keep on the remote way for the first weeks because
Okay.
we have some students that will also attend the course, but they are not in Brazil.
Okay.
So to start a course with just one or two people in the class, in the physical class, seems like strange.
Okay.
But I will let you know when we will start on the physical class. And guys, we will keep the remote classes too, okay? I will do both at the same time. Don't worry about that, okay? But I will let everyone know. And I also talk about the field work, and definitely this time the chair of the department confirmed that we have money. So yes, we have the field expedition will be great. If everyone that is in Brazil and wants to go to this field work will be really good. Okay?
Okay. I'm very interested to be part of it.
Great, Najib. It will be a very good time at the field.
All right. Thank you so much.
Okay. Thank you very much. So guys, thank you very much for your patience, for your time. I will share the link of this recording. I will share some references, and I will share also some other information that I think that could be interesting to you. Okay. If you need them, if you need any help, if you have any doubt, just let me know. Okay. So see
Okay,
you.
thank you so much.
Have-
Ciao.
Thank you. Thank you. Thank
Ciao.
you. Ciao. Have a great week.
Yeah.
Bye-bye.
And you too, bye.
Bye bye.
Just stop the recording. Stop the recording.